This homework solutions video is for Science and Mechanics, Unit 2, Force and Gravity, Section 3, Net Force in One Dimension. Number 1. A boat of mass 25 slugs has a 350-pound force applied by its propellers. The friction of the water on the hull is a force of 120 pounds. Find the acceleration of the boat. In Section 1 of Unit 2, we learned that acceleration is equal to a force divided by a mass. Now in this problem, we need to figure out what the net force is. Because we have the propeller applying a 350-pound force in one direction, and we have friction applying a force in the opposite direction. So the friction is applying a 120-pound force. So it's always helpful to sketch out a quick force diagram like what I have shown here to help us figure out what the net force is. So the net force will be the 350 pounds minus the 120 pounds from friction. So this gives us a net force of 230 pounds. So this is the force that we need to include in our formula to solve for the acceleration. So the net force we found was 230 pounds. The mass of the boat is 25 slugs. So our acceleration then, when we divide that out, is approximately 9.2 feet per second squared. Number 2. 4 people are having a tug of war. Al pulls from the left with a force of 70 pounds. Adam pulls from the right with a force of 90 pounds. Allie pulls from the left with a force of 80 pounds. With what force and direction should Alexis pull to make the rope hold still? Again, it's helpful to draw a force diagram so we can see which direction each of these forces are acting in. So Al pulls from the left with a force of 70 pounds. Allie also pulls from the left with a force of 80 pounds. And Adam pulls from the right with a force of 90 pounds. So the net force will add Al and Allie together. Their net force together was 150 pounds. And then Adam pulls from the right. So we'll take Adam's 90 pounds, subtract off the 150 pounds from Al and Allie. So that gives us a net force of negative 60 pounds. So that just tells us that the net force is acting to the left. So that means that Alexis, in order to make this rope hold still, needs to pull from the opposite side, from the right side. So she should pull with 60 pounds of force from the right. Number 3. A bridge has a weight limit of 5 tons. How heavy a load can a 3-ton truck carry across? So again, we want to make a rough sketch, draw our force diagram. So here's our bridge that can hold 5 tons, so it can support 5 tons, so that will act in the upwards direction. We have a 3-ton truck moving across the bridge, so again we need to find the net force. So the net force will be our 5-ton minus the 3-ton, so that gives us a net force of 2 tons. So this truck can carry a load of 2 tons across this bridge.